Hey guys, my name's William and today I'll be walking you through the 2022 FRQ number 4. To start off, we will be looking for the number of moles in 1 liter of the solution. They told us that the concentration is 0.0016 grams of NH2Cl over 1 liter. Now we're going to multiply that by the molar mass, which they have been kind enough to provide for us right here. Since grams is on the top for the grams per liter, we will be putting grams on the bottom. 1 mole on top. If we calculate that out in our calculator, we will get 3.1 times 10 to the negative 5 moles of the NH2Cl in a liter of that solution. Now for part B of this FRQ, it's looking for an explanation of why NH2Cl is more soluble in water than NCl3. Well, NH2Cl has some hydrogens hanging out on the top, as we can see here, which means that it is able to form hydrogen bonds with water. Sorry, I'm left-handed and so I'm covering up my writing. And as we know, hydrogen bonds are a very strong bond. And although it's called a bond, it's technically an IFA, intermolecular force of attraction. NCl3 does not have any hydrogens, so it can only form dipole-dipole bonds. Or forces, sorry. I'm trying to write and talk at the same time, which is not going well for me.
The elements of the periodic table.
These IFAs are weaker than hydrogen bonds. Because of this, NH2Cl dissolves a lot more readily than NCl3.
Iron is the 26th, then cobalt, nickel, coins again, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, thermal, krypton, helps light up your room, rubidium, and strontium, then yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silverware, then cadmium and indium, tin cans, antimony, then tellurium, and iodine, and xenon, and then cesium,
And then part C is looking for the amount of energy required. So it's given us 15 grams. So 15, don't forget your sig figs, guys. Though a lot of questions on the AP don't actually require the correct number of significant figures. This is a 3. It's not a very good 3. Okay, so we have 15 grams. So we are going to convert that into moles. Gives us the molar mass right here. So 1 mole of NCl3 is 120.36 grams. See, and it gives us the kilojoules per mole. They were very nice on this one. So In 1 mole of NCl3, we get 32.9 kilojoules. Doesn't look like it's asking for any specific unit of joules, so we can keep this answer in kilojoules, and that'll give us 4.11 kilojoules. We kept our sig figs. That's all for FRQ 4. If you wanted the grading for the correct answer, this would give you a point. Let's see if I can pull up the answer key to figure out, because part B was worth 2 points. Looks like you get a point for stating the type of, here we go. Get a point for the correct answer here. For this one, you'd get a point for stating the IFAs, so that would be plus 1 point here. And you'd also get the point for saying that the bonds for NH2Cl are stronger than for NCl, so that's another point. Which leads to the greater solubility, or dissolves more readily. And then for part C, you would get you'd get the point for the correct answer. That's all for FRQ4, guys. Thanks.